Can you explain in a way people would understand the difference between the way they were doing it and the way your team did it?
I can try.
That's all we can hope for.
Okay. So suppose you wanted to recognize a bird in an image.
Okay.
The image itself, let's suppose it's a 200 by 200 image. That's got 200 times 200 pixels, and each pixel has 3 values for the 3 colors RGB. And so you've got 200 by 200 by 3 numbers in the computer. It's just numbers in the computer, right? And the job is to take those numbers in the computer and convert them to a string that says bird.
Okay.
So how would you go about doing that? And for 50 years, people in standard AI tried to do that and couldn't. Okay, it's tricky to convert a bunch of numbers into a label that says bird. So here's a way you might go about it. At the first level of features, you might make feature detectors, things that detect little combinations of pixels.
Okay.
So you might make a feature detector that said, look, if all these pixels are dark and all these pixels are bright, I'm going to turn on.
Okay.
And so that feature detector would represent an edge here,
okay.
a vertical edge. You might have another one that said, if all these pixels are bright and all these pixels are dark, I'll turn on. That would be a feature detector that represented a horizontal edge.
Okay.
And you can have others for edges at different orientations.
We got a lot of work to do. All we've done is made a box.
Right. So we've got to have a whole lot of feature detectors like that. And that's what you actually have in your brain.
Okay.
So if you look in a cat or monkey cortex, it's got feature detectors like that. Then at the next level, you might say, if you were wiring it up by hand, you would create all these little feature detectors. At the next level, you would say, okay, suppose I have two edge detectors that join at a fine angle. That could just be a beak. So the next level up, we'll have a feature detector that detects 2 of the lower level detectors joining a fine angle.
Okay.
We might also notice a bunch of edges that sort of form a circle. We might have a detector for that.
Okay.
Then at the next level up, we might have a detector that says, hey, I find this beak-like thing, and I find a circular thing in roughly the right spatial relationship to make the eye and the beak of a bird. And so at the next level up, you'd have a bird detector that says, if I see those 2 there, I think it might be a bird.
Okay.
And you could imagine wiring all that up by hand.
Okay.
And so the idea of backpropagation is just put in random weights to begin with. And now the feature detectors would just be rubbish. They'd just be garbage.
Okay.
Okay. But look to see what it predicts.
Okay.
And if it happened to predict bird, it wouldn't. But if it happened to, leave the weights alone.
You got it right.
The connection strengths. But if it predicts cat, then what you do is you go backwards through the network and you ask the following question. And you can ask this with a branch of mathematics called calculus, but you just need to think about the question. And the question is, how should I change this connection strength so it's less likely to say cat and more likely to say bird? That's called the error, the discrepancy, right?
Okay.
And you figure out for every connection strength how I should change a little bit to make it more likely to say bird and less likely to say cat.
And a person's figuring that out, or the algorithm is set to
A
work?
person has said, this is a bird. So a person looked at the image and said it's a bird.
Yeah.
It's not a cat, it's a bird.
Yeah.
So that's a label supplied by a person.
Yeah.
But then the algorithm, backpropagation, is just a way of figuring out how to change every connection strength to make it more likely to say bird and less likely to say cat.
It just keeps trying. Keep turning the dials.
It just keeps doing that. And now if you showed enough birds and enough cats, when you showed a bird, it'll say bird, and when you showed a cat, it'll say cat. And it turns out that works much, much better than trying to wire everything by hand.